An alert spreads across the internet. Social media explodes. YouTube channels receive millions of views. The claim, 3I Atlas, a mysterious interstellar visitor, is accelerating faster than Oumuamua ever did, breaking the laws of physics right before our eyes. Observatories are supposedly baffled. Scientists allegedly cannot explain it. And according to some sources, NASA has gone silent because they don't want us to know the truth. But here's what actually happened, and it's far more interesting than the fiction. Because while 3I Atlas doesn't exist as claimed, the real story of interstellar objects, the genuine mysteries we've observed, and what scientists are actually discovering will fundamentally change how you think about what's traveling between the stars. If you want the real science behind the viral claims, hit that like button right now. And comment below, where did you first see the 3I Atlas story? Reddit? YouTube? A friend's message? Let's track how this claim spread across the internet. Let me be direct. There is no confirmed interstellar object designated 3I Atlas accelerating through our solar system. The International Astronomical Union, the only official body authorized to name celestial objects, has confirmed exactly 2 interstellar visitors. Oumuamua, discovered October 19, 2017, first confirmed interstellar object ever detected. 2I Borisov, discovered August 30, 2019. Second, confirmed visitor from beyond our solar system. That's the complete list. 2 objects, not 3. But here's where it gets interesting. The 3I Atlas story didn't emerge from nowhere. It's built on fragments of real science, genuine mysteries, and questions that astronomers are actually asking. Understanding where fiction ends and reality begins reveals something profound about how we process extraordinary claims. The 3I Atlas narrative is compelling because it exploits real gaps in our knowledge. It references actual telescopes, uses legitimate scientific terminology, and builds on mysteries that genuinely puzzle researchers. Here's what's real. Oumuamua exhibited unexplained acceleration. That's documented fact, published in peer-reviewed journals, confirmed by multiple independent observation networks. The acceleration violated predictions. Standard gravitational models couldn't account for the velocity changes measured by telescopes worldwide. No visible outgassing was detected. Unlike comets, which accelerate through gas jets, Oumuamua showed no coma, no tail, no obvious propulsion mechanism. These aren't conspiracy theories. These are legitimate scientific observations that researchers have been debating since 2017. But the 3I Atlas story takes these real mysteries and adds invented details. Specific acceleration rates that don't exist in any database, observatory alerts that were never issued, NASA statements that were never made. Let's talk about what actually happened with Oumuamua, because the truth is stranger than most fiction. October 19, 2017, the Pan-STARRS telescope in Hawaii detects an object moving at extraordinary speed. Initial observations show a hyperbolic trajectory. Not elliptical like solar system objects, hyperbolic, meaning it came from interstellar space and would never return. Astronomers worldwide scramble to observe before it vanishes. Every major telescope redirects. Time is critical because Oumuamua is moving at 87,000 kilometers per hour relative to the Sun. The data reveals something unprecedented. As Oumuamua recedes from the Sun, it accelerates slightly beyond what gravity predicts. The deviation is small, measured in millimeters per second squared, but it's real and is consistent across multiple observation sessions. Dr. Marco Michelli from the European Space Agency led the team that documented this acceleration. Their paper, published in Nature in June 2018, presented the evidence with scientific precision. Non-gravitational acceleration detected, magnitude, approximately 1 × 10 to the -4 meters per second squared. Direction, radially away from the Sun with a slight tangential component. This is what real anomalies look like. Not dramatic, not sensational. Careful measurements, peer-reviewed analysis, acknowledged uncertainty. The researchers proposed outgassing as the most likely explanation. Even though no coma was visible, perhaps Oumuamua was venting gas too faint to detect, creating subtle thrust like a natural rocket engine. But problems emerged. Standard comet models predict certain ratios between acceleration and observable activity. Oumuamua's acceleration to brightness ratio didn't match. If outgassing was producing that much thrust, we should have seen something: dust, gas, any signature of material leaving the surface. We didn't. This gap between observation and explanation created space for alternative ideas. Dr. Avi Loeb from Harvard proposed that Oumuamua could be a light sail, a thin reflective structure accelerated by solar radiation pressure. His hypothesis generated massive attention, not because it was proven, but because it challenged assumptions about what interstellar objects could be. The scientific community responded with a mix of interest and skepticism. Light sails are theoretically possible, but natural formation of such structures faces significant challenges, and invoking artificial origin requires extraordinary evidence. Other researchers proposed different mechanisms. Perhaps Oumuamua contained unusual ices, hydrogen trapped in molecular form that sublimated without producing visible dust. Perhaps its shape, potentially very elongated, created asymmetric radiation pressure effects. Perhaps we're missing physics we haven't yet characterized. Each hypothesis has supporters. Each faces objections. The debate continues because the data doesn't decisively favor any single explanation. This is how real science works: multiple competing ideas, ongoing research, acknowledged uncertainty. Not definitive claims, not NASA cover-ups. Researchers wrestling with observations that don't fit existing models. The second confirmed interstellar visitor provided a stark contrast. Gennady Borisov, an amateur astronomer in Crimea, discovered it on August 30th, 2019, using a telescope he built himself. Professional observatories confirmed the discovery within days. Borisov behaved exactly like astronomers expected interstellar comets to behave. It developed a visible coma as solar heating vaporized surface ices. It formed a tail streaming behind it, blown by solar wind. Spectroscopy revealed familiar chemistry: water vapor, carbon monoxide, carbon dioxide. Composition matching solar system comets. Its brightness varied predictably with distance from the sun. Its trajectory followed standard gravitational models with minor non-gravitational acceleration consistent with visible outgassing. Borisov was, in the best possible way, boring. It confirmed that interstellar comets exist and that most probably behave conventionally, following physics we understand. This context matters. One anomaly, Oumuamua, that challenges models. One normal comet, Borisov, that confirms models. And now claims about a third object that supposedly breaks everything. Except that third object doesn't exist in any official catalog. So if 3I Atlas isn't real, where did the story originate? Several factors converged. The Atlas Survey System, Asteroid Terrestrial Impact Last Alert System, is a real telescope network that has discovered numerous comets. Some of these comets have Atlas in their designation because that's the survey that found them. But none are confirmed interstellar objects with mysterious acceleration exceeding Oumuamua. Online, speculation blends with fact. Someone notes that Atlas discovered a comet. Another person remembers Oumuamua's anomalies. A third combines these ideas, adding dramatic details about acceleration and NASA alerts. The story spreads. Each retelling adds embellishments. YouTube channels produce videos with compelling visuals and dramatic narration. Social media algorithms amplify engagement, pushing the content to millions of viewers. Within weeks, 3I Atlas becomes common knowledge, despite never appearing in any peer-reviewed paper, any official IAU bulletin, any NASA press release. This isn't malicious. It's how modern information ecosystems work. Compelling stories spread faster than careful correction. And stories about mysterious space objects breaking physics are extremely compelling. You might think this is harmless speculation, just internet entertainment, but it has consequences. First, it undermines trust in real science. When people discover that 3I Atlas isn't real, some conclude that all interstellar object research is unreliable. The genuine mysteries of Oumuamua get dismissed as more internet nonsense. Second, it exploits curiosity. People genuinely want to understand space, to learn about discoveries, to engage with science. Creating fictional discoveries to capitalize on that curiosity is fundamentally dishonest. Third, it makes future communication harder. When the actual third interstellar object is eventually confirmed, and it will be, some people will remember 3I Atlas and assume this new discovery is another hoax. Fourth, it drowns out real questions. Oumuamua genuinely puzzles scientists. That puzzle deserves serious discussion based on actual data, not speculation about non-existent objects. Instead of focusing on verification tips, let's dive deeper into what genuinely makes interstellar objects fascinating. Oumuamua and 2I Borisov provide real data that challenge and expand our understanding of objects from beyond our solar system. Here are some of the intriguing aspects. Shape and rotation. Oumuamua appeared highly elongated or possibly pancake-shaped. It also tumbles irregularly rather than spinning around a single axis, which affects how sunlight impacts its motion. Acceleration. Its slight non-gravitational acceleration remains unexplained. While subtle, this deviation challenged astronomers and prompted several hypotheses, from outgassing to solar radiation pressure. Composition. 2I Borisov behaved more like a typical comet, with water, carbon monoxide, and carbon dioxide detected in its coma. But Oumuamua showed almost no visible activity, hinting at a different composition or structure. Trajectory and origins. Both objects entered our solar system from interstellar space on hyperbolic paths that will never return. Their motion provides clues about material exchange between star systems and the diversity of planetary formation processes. Scientific mystery. The ongoing debates about these objects, how they accelerate, their shapes, and composition highlight the uncertainties and excitement inherent in studying interstellar visitors. Every new detection challenges models and may reshape our understanding of cosmic objects. By examining the real properties of known interstellar objects, we gain insight into the complexity of the universe. The data itself is compelling enough. We don't need fabricated stories to inspire awe or curiosity. Instead of focusing on fictional objects, let's discuss what genuinely puzzles astronomers right now. Oumuamua's acceleration mechanism remains unresolved. Multiple hypotheses exist, none definitively proven. Research continues as scientists refine models and debate interpretations. Some recent work suggests that hydrogen outgassing could explain the acceleration without producing visible coma. Hydrogen molecules trapped in ice during formation in extremely cold interstellar space could sublimate when heated by the sun. Hydrogen is nearly impossible to detect remotely, which would explain why we saw acceleration but no visible activity. This hypothesis fits some observations but faces challenges. The quantity of hydrogen required is substantial. The mechanism for trapping it during formation requires specific conditions. Not everyone is convinced, but it's a serious scientific proposal being evaluated through normal peer review processes. Other researchers continue exploring the light sail hypothesis, not because they're certain Oumuamua is artificial, but because ruling out possibilities requires thorough investigation. If we dismiss ideas prematurely, we might miss genuine discoveries. The shape of Oumuamua also remains uncertain. Early estimates suggested extreme elongation, possibly 10 to 1 length to width ratio. More recent analysis suggests it might be flatter, like a pancake rather than a cigar. Its rotation appears complex, tumbling rather than spinning around a single axis. These are real puzzles being addressed through real research. Papers are published. Researchers debate interpretations at conferences. New observations refine understanding. This is science in action, messy and uncertain, but progressing toward better models. The search for interstellar objects continues with dramatically improved capabilities. The Veracruz Observatory in Chile will begin operations soon. Its massive camera will image the entire visible sky every few nights, detecting fast-moving, faint objects that previous surveys missed. Statistical models predict that detectable interstellar objects pass through the inner solar system roughly once per year. Most go unnoticed because they're faint, or we're not looking in the right direction. Rubin's comprehensive coverage will find more of them. When the third interstellar visitor is confirmed, it will follow established protocols. The Minor Planet Center will assign a provisional designation. Multiple observatories will confirm the hyperbolic trajectory. Researchers will publish findings in peer-reviewed journals. NASA and ESA will issue official press releases. The discovery will be documented transparently, with data accessible to anyone who wants to verify the observations. Oumuamua taught us profound lessons beyond its specific mysteries. It demonstrated that interstellar objects are detectable with current technology. We're not limited to theory. We can observe actual visitors from other stellar systems. It revealed gaps in our models. Theories developed studying solar system objects don't automatically apply to interstellar visitors. Different formation environments produce different properties. It sparked legitimate scientific debate. Researchers with different expertise, observational astronomers, theoretical physicists, planetary scientists, brought diverse perspectives to interpreting unusual data. It showed that anomalies drive progress. When observations don't match predictions, science advances. We refine models, propose new mechanisms, design better observations, and it demonstrated public fascination with interstellar visitors. People care about these discoveries. They want to understand what's traveling between stars. That enthusiasm should be channeled toward real science, not fictional stories. Step back from individual objects. Consider what this means for understanding the galaxy. Billions of stars exist in the Milky Way. Each potentially hosts planets, comets, asteroids. Gravitational interactions eject objects from their home systems regularly. These objects drift through interstellar space for millions or billions of years. The galaxy should be filled with such wanderers. Statistical estimates suggest trillions of interstellar objects larger than 100 meters diameter traverse the galaxy at any moment. Most will never enter another stellar system. Space is vast. The average distance between stars is measured in light years. But occasionally, probabilistically, some objects pass through solar systems. We're finally detecting them. And each detection provides a snapshot of conditions elsewhere, samples of material formed around other stars, evidence of how planetary systems evolve in diverse environments. This isn't speculation. This is data-driven science, revealing the chemical and physical diversity of our galaxy. Let's return to the original claim. Is 3I Atlas accelerating faster than Oumuamua? The question is meaningless because 3I Atlas doesn't exist. But let's address the underlying curiosity. How fast was Oumuamua accelerating? And what would faster acceleration look like? Oumuamua's non-gravitational acceleration was approximately 10 to the negative 4 meters per second squared. That's 1/10,000th of a meter per second squared. Tiny, but measurable with precise astrometry. For comparison, Earth's gravitational acceleration at surface level is roughly 10 meters per second squared. Oumuamua's anomalous acceleration was 100,000 times weaker than Earth's gravity. An object accelerating faster than Oumuamua would need non-gravitational forces exceeding 10 to the negative 4 meters per second squared. This could occur through several mechanisms. Stronger outgassing would produce higher acceleration. A comet with more volatile material venting more vigorously would accelerate more dramatically. Lighter mass with similar thrust would increase acceleration. If a thin, sail-like structure experienced radiation pressure, its acceleration could exceed that of a denser object. Closer proximity to the Sun would increase radiation pressure and heating, potentially producing stronger effects. But none of these scenarios describes a confirmed object. They're theoretical possibilities, and distinguishing between them requires actual observations, not speculation. Here's what genuinely excites me. We live in an era where detecting visitors from other star systems is becoming routine. 20 years ago, we had never observed an interstellar object. The concept existed only in theory. We knew they must exist statistically, but we'd never seen one. Now, in less than a decade, we've confirmed two: Oumuamua, mysterious and anomalous; 2I Borisov, reassuringly normal. And we're developing capabilities to find more. Within your lifetime, we'll likely detect dozens of interstellar visitors. We'll learn about formation conditions around different types of stars. We'll discover materials processed in alien radiation environments. We'll refine models of how planetary systems evolve and interact. The European Space Agency's Comet Interceptor mission, scheduled for launch in the late 2020s, is specifically designed for rapid deployment to newly discovered objects. If we detect another interstellar visitor early enough, Comet Interceptor could reach it, collecting close-up images and direct measurements. Imagine that, a spacecraft from Earth intercepting an object from another star system, analyzing its composition directly, imaging its surface, measuring properties that telescopes can only infer. That's not science fiction. That's planned science waiting for the right opportunity. Some of you might be wondering, if 3I Atlas isn't real, why does it matter? It's simple. The story reminds us that the universe itself is already full of mysteries. Is 3I Atlas accelerating faster than Oumuamua? No. That object, as described online, doesn't exist. But Oumuamua is real, and its slight acceleration as it passed through our solar system remains one of the most fascinating puzzles in recent astronomy. 2I Borisov, the second confirmed interstellar visitor, behaved much more predictably, showing us that interstellar objects can follow familiar patterns. The point is this: the universe provides mysteries that are amazing on their own. Oumuamua challenges our understanding. 2I Borisov confirms that our models work in other cases. And as we develop better telescopes and detection systems, we will continue to discover more objects from beyond our solar system, each one telling us something new about how planetary systems form, evolve, and interact across the galaxy. The search continues. Real interstellar objects are moving through our solar system right now, waiting to be observed and studied. The next one could arrive at any moment, and when it does, scientists will learn from it, not from speculation, but from real, measurable data. The universe is strange, complex, and fascinating enough. We don't need fictional objects to be amazed. Keep looking up, stay curious, and enjoy the wonder of real discoveries.